Hello, so today I'm going to talk about the law of sines. Now, the law of sines is essentially determined by um, this ratio of sine of angle A divided by A is equal to sine of B divided by B equals to sine of C all divided by, we'll just say little c. Now, the um, the data of which that you would need, for example, for solving a problem dealing with law of sines, is that you would need either the angle side angle case or the side angle angle. The other case is of which that you could have the side angle, and then another case is the side angle side, and then another case could be if we have um, all three sides. Now, the first two, that's using law of sines. The other two down over here, the side angle side and then the side, those will require the law of cosines. Now, the only problem with using law of sine is that whenever you have a side angle, this is what we call the ambiguous case. Mostly because it's not clear whether we have one triangle, two triangles, or maybe even none. Now, the other possibility that we can have is that the sum, well, not really a possibility, but more or less like a condition, is that A plus B plus C equals to 180 degrees. That's just pretty standard when it comes to a triangle that you might have. Otherwise, if it doesn't equal to 180, or if it's more than 180, then it's not really a triangle. Most likely you have like a not that you have that it's not enclosed. Now, what I'd like to do is kind of show just like how I can apply the law of sines using an example. Now, typically you'll be given, again, like some set of data. Um, and to be honest, I normally don't really get too caught up on like which case am I using because I can just work off of that. So like for example, if I have that A equals to 40 degrees and then I have that C equals to, not C but B, if I have that B equals to 60 degrees followed by that A equals to 4 centimeters. Now, we could probably draw the diagram as needed. But it's gonna be a little strange because, for instance, we have that the angle for A is, well, it's roughly, we could probably say that it looks something like this. But, this is not really to scale, to be honest. So, like, for example, like we know that this is 40 degrees. We know that this side right here is 4 centimeters. But we don't know, for example, like, uh, that what side B is. So we have this is side B. And then we actually don't know what angle C is. For that matter, we don't know what side C is either. But we can actually solve this easily by taking that A plus B plus C is equal to, and I'll try to make my C's like big enough so that way you can kind of tell the difference. Some people use alpha, beta, gamma, um, but it's all the same. So you have that, that's going to be 40 plus 60 degrees plus C, and we have that all of that is equal to 180. So that tells me that angle measure C equals to 80 degrees. So I have that this is equal to 80 degrees. Now, if we want to find the other missing sides, all that we need to do is to apply our formula. So the formula states that we have that sine of A over little a is equal to sine of B all over B, and this equals to sine of C all over little c. Now, what I'm going to do next is I'm going to try to find angle measure B, not angle measure B, but side B. So the way that I'm going to do that is I'm just going to say, well, I have B divided by sine of 60 equals to, well, let's use the things that we know. We know that if we set it equal to, say for example, sine of A over A, well, that's really just going to be 4 divided by sine of 40, and all that we need to do here is just multiply side B by 60, sine 60 multiplied by 4 divided by sine 40 degrees. Now, if we actually plug this into our calculator, that's actually pretty simple. So like, let's say for example, we use our calculator, and I'll just leave this open since we're going to end up using some of the, we're going to need the calculator to do the computations. So let's go ahead and not only change the mode, but we're also going to clear out the calculator. So let's just clear this. Okay. So we had that we were going to multiply 4 by sine of 60, but we also have that we're going to divide this by sine of 40. And we're just going to hit enter. And that gives me that B is approximately 5.39 centimeters. Now, keep in mind that we cannot use Pythagorean theorem at all because this does not involve a right triangle. So we have one more side to deal with. Let's just write it over here, and that way we save some space. So we have that C is equal, or C is divided by sine of 100 degrees, or no, 80. 80 degrees equals to, we'll just use 4 over sine of 40. So we get that C is equal to, symbolically, 4 times sine of 80 degrees, all divided by sine of 40. Now, when we go ahead and we simplify this, we're just going to reduce down to 2 decimal places. So why don't we do this? We'll just go ahead and scroll up, and since we know that it's going to be sine of 80 degrees, why don't we just replace this with an 8, and then we'll just get rid of that. And that should be good to go. So we just push enter, and we get 6.13 centimeters. So that's going to be 6.13 centimeters. So we have our answer, essentially, or answers for that matter. 6.13 centimeters for C, 5.39 for B, And then we mentioned that the angle measure that we got was 80 degrees. So usually we'll try to find all of those bits of information. Now we can actually go ahead and look at, for example, um, what if we had that we just wanted to know, how exactly did we get the law of sines to begin with? Well, let's just think about it like this. Suppose that you have a triangle, and let's say that, for example, that you had sides A, or angle A, side A, angle B, side B, and then you have angle C, and then you have little c. Well, what if I were to drop the altitude of this, where I form a right degree, or right angle? And what we can do here is label the bisecting line as the height. So one thing that I'll notice is that if I go ahead and I try to find sine of A based on this diagram, I have that sine of A is going to be relative to here. I have that it's going to be h over c because I have a right triangle. Okay, but let's see, if we use sine of c, okay, so sine of c is equal to, um, let's see, yes, so that's going to be h over a. Now, if we go ahead and we look at this, we know that the h equals to c sine of a, and we also know that the h equals to a sine of c. But notice that we have that both of these two are equal to h. So what that does is it tells us that c sine of a equals to a sine of big C. So this gives us the first part of the law of sines, or at least one part of it, so that you have sine of a over a equals to sine of c, all divided by little c. Now, it might be somewhat difficult, like if we look at, for example, angle measure B, but for that you would have to consider a different triangle where the height is more or less like something like where you have um, something like this. So notice that the height is actually now down over here, if we think about that. Okay, so in this case, like you can do the same, I guess you can say proof that you have that these sides can be respectively B, B, and then this would be C, and then this would be C, and then this would be angle A, so that means that this is side A. So you can still derive the remaining relationships between the two. Um, so like you would use more or less like sine of B and sine of C, and then you would end up using some type of transitivity law that would say that, well, that must mean that, once you do the derivation, of course, that you have that sine of A over A equals to sine of B over B, and then you have that this equals to sine of C divided by C. Just make sure that it's understood that that's a smaller um, that's a smaller one. So let's see. So yeah, yeah, so this should give you the remaining formulas, if anything. Um, let's go ahead and look at, for example, a problem where you're trying to use the application process, like just like, an example where you try to use law of sines. So let's say that there's a river. Okay, so we're just going to say that there's a river, and we don't know the width of this river, but we definitely know that, yeah, that this river runs whichever way. And we're just going to draw, like, say, for example, a horizontal line right through there. And for this particular example, we have that this will be one point, this will be another, but you're going to have like another sighting. So for example, like if we put another point right there, so this would be B, this would be C, and then this would be A. So if I connect these lines like so, okay, ignore this. This is supposed to be over there, or maybe I can just undo that. Yeah, even though it does look nicer, to be honest. Let's see. Okay, so the thing of which that we do know about this problem is that the angle that forms right here at C is a 117.2 degrees. The other thing of which that we do know is that the angle right here is 28.8 degrees. Now the other thing that I do happen to know is that this side right here is 75.6 feet. So I just need to be able to find the distance across here. So we can actually label that as follows. So we're just trying to find side A. Okay, so the thing about this though is that I just need to figure out, for example, like what is the angle measure B? Well, let's do it like this. We know that B equals to 180 minus 117.2 degrees, 20 degrees, minus 28.8 degrees. So if we do this using our calculator, we have that 180 minus 117.20 minus 28.8 degrees. That's 34 degrees. So we have that the angle that forms is 34 degrees. Now, the rest of this requires that we find A. So we'll just write that A divided by sine of 28.8 is equal to, well, we know that that's going to be 75.6 divided by sine of 34. So that means that symbolically that A is equal to 75.6 times sine of 28.8 degrees, all divided by sine of 34. So in actuality, this answer is not too bad because it's just really having to cross multiply almost. So 75.6 multiplied by sine of, let's see, what did we have? We had sine of 28.8. Okay, so 28.8, close it, and divide by sine of 34 degrees. We hit enter, and we get that the distance across the river is 65.1 feet. Okay, so definitely our scale is not accurate, but that's okay. I mean, this is just pure instruction, if anything, where you're just trying to apply the formula. But most definitely, if this was like a project that you were working on, then yeah, you would have to probably be a bit more accurate in your scale. So this is going to be 65.1 feet, and that's it. So that was pretty easy. Now, note that the um, let's see. Note that the example here was actually an application of using the angle side angle. Why? Because you were using the two angles in the side. So that just told us that we were using angle side angle. Now it's all the same though. If you're like, oh, but I thought it was side angle angle or angle side angle. I mean, I don't normally don't get too caught up on it because I know that if I just use the formula that it's all gonna work out. Okay, so the last thing that I can talk about is looking at, for example, if we were to um, apply um, side angle angle. Okay, so if we do side angle angle, let's say that you have the following. You have that angle A is equal to 28.8 degrees, and then you also have that C is equal to 102.6 degrees. Furthermore, you have that side C is equal to 25.3 inches. Okay, so the next step is that you would need to basically apply the law of sines. So again, here it doesn't technically matter if we draw the diagram or not. I mean, you can, but in either case, I mean, you know that the things that you're going to use is that side angle B is 180 minus 102.6 degrees minus 28.8 degrees, which that's going to equal to 48.6 degrees. Well, the rest of this is really just using that, for example, that 25.3 divided by sine of 102.6 degrees is equal to, well, that's going to be equal to A over sine 28.8 degrees, and then that's going to be equal to B divided by, let's see, sine of 48.6. I would say, try to solve these problems on your own where you're able to figure out like what is A and what is B. But again, you're not using Pythagorean theorem at all in this case because it's not a right triangle. So if you do that, you should get that angles side A using the algebra, like if you cross multiply, you'll get that side A is equal to 12.5 inches. Now, if we look for side C, well, side C, not side C because we already know that, side B. Side B is going to be 19.4 inches. So these are the two solutions that you should get when you plug in or when you apply law of sines. Um, so try to do that by using the above or this formula right here, because that's basically the key, is that A is just sine of 28.8 times this ratio, B is sine 48.6 times this ratio, and then that should give you what you want. Okay, so I'm gonna stop right there, but just be sure that you do look at things like the area. But the area is actually pretty easy because you're just using two sides that are given and the angle. So it's gonna be always like 1/2 times the two sides times the sine of the angle. So just be sure that you do look at that.